In this lesson video, we will learn the angles property of higher order polygon, that is polygon with more than 4 arms like pentagon, hexagon, heptagon, octagon and so on. So firstly, we will learn about the interior angles of a polygon and practice some examples. Then we will learn about the exterior angles of polygon and then practice some examples. A polygon is called n-gon if it has n arms. So for example, this polygon got 3 arms, so it's a 3-gon. We can write it 3-gon, which is triangle. If a polygon got 4 arms, then it's a 4-gon. We can write it as a 4-gon, but its common name is quadrilateral. If a polygon got 5 arms, 1, 2, 3, 4, 5, then it is called pentagon. If a polygon got 6 arms, then it is called hexagon. So n equals 6. So in this way, in general, we can say if a polygon has n arms, then it's an n-gon. Here we will find a formula to get the sum of n interior angles. If a polygon got 3 arms, then it has 3 interior angles. If a polygon has 4 arms, then it got 4 interior angle. For a polygon with 5 arms, that is pentagon, got 5 interior angles. Hexagon, that is a polygon with 6 arms, got 6 interior angles. That means a polygon with n arms, that is an n-gon, will have n interior angles. Here we will find a formula, general formula, to find the sum of n interior angles of any n-gon. That is, for any value, that formula will be valid. Let us develop step by step. For a triangle, when n is 3, that is the number of arms is 3, so there are only one triangle here, and we know the sum of 3 angles of a triangle is 180 degree. So sum of all interior angles is 180 degree when n is 3. When n is 4, that is for quadrilateral, there are 2 triangles. If we divide the quadrilateral, we will get 2 triangles, and each of them will give 180 degree and 180 degree, because its internal angles are 180 degree and this one's internal angles are 180 degree. So for a quadrilateral, the total internal angle will be 2 times 180 degree. That we already know, 360 degree. So when n is 4, it is 2 times 180 degree. Let us consider for pentagon. A pentagon got 5 arms, so 5 angles. We can divide a pentagon into 3 triangles. So each of the triangle will give 180, 180 and 180. So the total internal angles, sum of all internal angles, will be 3 times 180. So when n is 5, it is giving 3 times 180. Similarly, for a hexagon, when the number of internal angles are 6, we can divide it into 1, 2, 3, 4 triangles. That is, each of the triangle will give 180 degree internal angles, 180 degree and 180 degree. So 4 times 180 degree. So when n is 6, it is giving 4 times 180 degree. There is a pattern. If we see carefully, when n is 3, then 1 times 180 degree, which can be written as n minus 2. That is, n is 3, so 3 minus 2 times 180 degree. That is 1 times 180 degree. When n is 4, then we are getting 2 times 180 degree, which can be written as 4 minus 2, that is n minus 2 times 180 degree. When n is 5, we are getting 3 times 180 degree, which can be written as 5 minus 2, that is n minus 2 times 180 degree. When n is 6, we are getting 4 times 180 degree, which is 6 minus 2 times 180 degree, that is n minus 2 times 80 degree. So every time we are getting n minus 2, whatever with the n. For triangle n is 3, for quadrilateral n is 4, for pentagon n is 5, for hexagon n is 6. If we go 7, 8, 9, it is always valid that n minus 2 times 180 degree. So that is, in general, as a general formula, you can say the sum of all n interior angles of a n-side polygon will be n minus 2 times 180 degree. So this is the formula we will be using, that if a polygon has n interior angles, that is, the polygon has n sides and there will be n interior angles, their summation will be, sum of all n interior angles will be n minus 2 times 180.